Now that you've practiced with the exponential logarithmic inverse relationship, let's use that idea to solve some exponential equations. I'll do the first one, and I'll do both the solve and the check, and then there'll be a few for you. Remember that an exponential has a fixed base but a variable exponent. In a case like that, we undo the exponential with a logarithm. But before we operate on both sides, we have to decide, are we going to use log or ln? And because this is a base of 10, I'll be using log. First, I'll be taking the log of both sides. And now, keeping in mind that log is log base 10, I'll be making use of this idea, and I'll replace the entire expression with the exponent, and my answer is log of 7. And if you put that in your calculator, you'll get a decimal approximation. It's approximately equal to this, but we like to keep the original, which is exactly right, not approximately right. If we're applying the problem, then we often use this approximation. To check my work, I return to the original. I replace x with my answer. I recall that log is log base 10, and so now I'm going to use this idea and replace this expression with 7. My values match, because originally I wanted it to be equal to 7, and so I'm confident in my answer. Try this one. Here we have a base of e, so I'm going to take the natural logarithm of both sides. Keeping in mind that ln is log base e, I'm now going to make use of this idea and replace the entire expression with x. Here's my answer. To check my work, I return to the original. I replace x with my answer. I keep in mind ln is log base e, which means I now have this idea. And I can replace this entire expression with 0.5, and that's a match to the value I was hoping it would become. How about here? Again, because the base is e, we'll take the natural logarithm of both expressions. On the left, we're working with this relationship. We can replace the entire expression with simply t. We've now solved for t. Now, in this case, let's say this was an applied problem. This isn't something we want to do very often, but I just want to make a point. Keep in mind that this number is close to this number. And in cases like that, if you want to check the value, you don't have to use the exponential logarithmic relationship. You can just put this in your calculator, and you'll notice that we're off by 4, and that's because we rounded up here a little bit. Again, this is just approximately equal to this. Try this one. Because our base is 10, we're going to take the log of both sides. Over on the left, we have this arrangement. We can replace the expression simply with the exponent. We now have solved the equation. We go back to the original. We replace the variable with our answer. Then we use this idea to replace the entire expression with 20. It's a match, and we're confident in our answer. Well, that will conclude this video where we've begun solving exponential equations.